Hello, everyone. Thanks for joining us today. We'll be covering how to supercharge your enterprise AI with real-world exploitability data today. So during today's agenda, we'll cover three primary things. First, why the FixOps revolution demands a new approach to security automation. Second, how the MCP architecture enables AI to act on exploitability intelligence. And third, specific workflows showing the before and after transformation when you inject proof into your security ecosystem. And so let's start with why this matters now. I'm excited to talk today about something that's been keeping CISOs and security leaders up at night, but probably not for the reasons that you're thinking. So picture this, right? Your vulnerability scanner just finished its weekly run. The report lands in your inbox, 10,000 findings. Critical CVEs everywhere, misconfigurations, exposed credentials, privilege escalation paths, the works. And so here's the question that immediately hits you. Which 10 of these 10,000 can an attacker actually exploit right now? And what happens when they do? Because here's what we know, right? Not all vulnerabilities affect every organization with the same negative impact. And that critical CVE that's making headlines, it might be completely unexploitable in your environment, but that medium severity finding everyone that everyone's ignoring could be your organization's fastest path to being compromised. And so for years, we've been fighting the wrong battle. We've been optimizing for speed of detection when what actually matters is speed of fixing what matters. And that's the challenge we're going to solve here today. So the FixOps problem. For the longest time, security was all about speed of detection. Who can find the threat fastest? Who has the best monitoring? Who catches the anomaly first, right? And don't get me wrong, detection matters, but we're living in an era of machine speed versus machine speed, meaning attackers aren't slowing down to let us catch up. And so they're automating everything from reconnaissance to exploitation to lateral movement. And so detection speed doesn't necessarily matter if you can't fix what matters first, right? And so that's what I call the FixOps revolution. Traditional security alerts on everything with equal urgency, something similar to, let's say, a smoke detector that can't distinguish between burnt toast and a 4-alarm fire. And what we really need is a smart fire suppression system, right? Something that knows the difference and automatically takes the right action. And so here's the challenge. The average enterprise spends around 200 hours monthly just on the vulnerability research and prioritization process. 200 hours, right? So that's time that could be spent on strategic security improvements. Now, manual triage is the enemy of speed, but rushing to automate without trustworthy data, that's how you automate bad decisions at machine scale. And so what we need are tools that make quick, trustworthy, automated decisions, intelligence that tells us what matters to our specific organization, context-driven automation, not just faster manual processes. And so to solve this, we really need a fundamentally different architecture, one that connects AI reasoning with exploit-level intelligence, and that's where the MCP ecosystem comes in, as well as the whole NodeZero, which I'll cover in a second. So let me just talk about MCP servers for a second. Based on the attendee list that I saw, I think half of you are deeply technical, half of you are here to just understand what's possible first. And I'm going to give you a little bit of both. And so traditional integrations, right? When it comes to when it comes to setting up an integration, let's say across two tools, point-to-point can be a nightmare. I think every blue teamer knows that. And every tool needs essentially custom connectors to every other tool. Even if they have a native integration, it requires some wiring up between two vendors to make sure that their data is playing nicely. So it becomes an n-squared complexity that simply doesn't scale. And so the MCP approach is fundamentally different. Think of it as a universal translator at a United Nations meeting. Instead of needing interpreters for every possible language pair, you have one system that understands what everybody means and then is able to facilitate conversation between any parties. And so the three key components for an ecosystem like this, right, is first the LLM, the brain that thinks semantically about objectives, not API calls. Second, the MCP server itself, right, that translator that I mentioned that exposes tools in formats that LLMs understand. And then third, the tools and resources itself, the workers that actually execute action. And so if we're walking through this in a similar flow, we start to think, okay, so a user asks, what are my top exploitability vulnerabilities affecting production databases? The LLM is thinking, well, I need to query NodeZero, probably filter by exploitability, cross-reference with production database tags that already exist, and then rank it by impact, right? So the MCP server is essentially translating that into 4 API calls in sequence, and then the results flow back with, hey, 3 findings, let's say, with active exploit paths to your production databases ranked by blast radius. And so what we're trying to enable is more thinking by AI, less configuration by humans. And the critical distinction here is that not all MCP servers are created equal. For me, when we were building the NodeZero MCP server, upon lots and lots of research, the truly effective MCP server does 3 primary things. First, it exposes unique expert-level data. In our case, exploitability intelligence, proof of exploit, downstream impact. Second, it provides contextual resources, not just here's a vulnerability, but here's the attack path. Here's the exploit path, what attackers can reach, and your fix options as well. Third, it enables autonomous capabilities, right? A query tells you what's wrong, but autonomous capabilities let the AI actually fix it and then go so far as to verifying if something was fixed. And so the quality of AI decisions scales with data quality. Automate with poor data, and you're going to accelerate bad decisions. Automate with exploit level intelligence in this scenario, and you'll match machine speed threats with machine speed responses. And that's why you need to feed these systems, and what you feed these systems matter. And so let's look at how this works actually in practice. And so if we're comparing the legacy versus agentic AI workflows, let's talk about the difference between traditional and agentic, right? In traditional automation security, you've got dozens of rigid playbooks for dozens of different scenarios, human in the loop at every single decision point, and it's deterministic, it's brittle logic that breaks when anything changes, and it's basic things like if scanner finds X, create ticket Y assigned to team Z. And so the moment anything changes, a new tool, new vulnerability type, a new team structure, even CVSS updating their scoring logic, the whole thing breaks, right? And so you're back to updating playbooks again. And it's like, so for me, the analogy there is it's sort of like having a robot that can vacuum your floor perfectly until it encounters a sock, right? It then has to stop and wait for you to come and move the sock before it kicks off again. And so agentic AI workflows are different. They understand objectives, not just rules, and they're able to use contextual decision-making across multiple data sources. They take autonomous action within defined guardrails, and they adapt to new scenarios without necessarily needing fresh and new playbooks. And it's like having a colleague at that point who understands your goals. You say, hey, we really need to secure our production environment before the audit. And that colleague, very helpfully, they figure out the steps, they gather the context, they come back with options and say, this is what I would do. And it's not just alerts at that point. But here's the catch. Autonomy without accuracy is going to just be automation of mistakes at scale. And so the question isn't whether to use agentic AI. Your competitors, even your enemies, the bad guys, are already using it. The question is, what separates trustworthy AI from automation of mistakes at scale? And that brings us to the foundations of trust here. And so the three pillars of what it takes to be reliable AI in security specifically. There was an interesting blog from one of our investors, Signal Fire, that covered this recently. I've seen a bunch of validation from industry experts who also emphasize that highly contextualized and expert data sets separate useful AI from dangerous or even useless AI. And so the three pillars that enable trustworthy AI decisions in security is going to be pillar one, right? Scalable simplicity. It's a natural language interface that's working consistently with minimal configuration. For me, the importance of this is that it democratizes complex offensive security concepts, making what was previously, right, expert knowledge accessible to anyone so that they can make better decisions. And so that drives adoption through ease of use and offers portability without compromising on security. And so enterprise security teams are stretched thin. The reality of it is that tools that require extensive training or even configuration is not going to achieve organization-wide adoption, and you're not going to get return on investment on it. So pillar two, one of, in my opinion, the most important pillar, high quality, highly contextual data. And this is where, in my opinion, most solutions fall short. So generic vulnerability data, for example, table stakes, right? Theoretical risk scores, everybody has those. Now, what makes a difference in terms of context in light of this exercise here is that it's context specific to your environment. And so expert level intelligence that would normally take humans hours, if not weeks, if not months to gather, that's the massive difference, right? So it's a difference between knowing that, hey, CVE 2025 1234 exists, and knowing that CVE that CVE is exploitable specific to your production environment, and then understanding even that, hey, for you guys, the attacker is able to get domain admin access, and here's the proof that would be associated with it. And so a critical CVE might be completely unexploitable in your environment. A medium CVE might at the same time be the fastest path to your total compromise. And if you think about it, generic risk scoring cannot tell the difference. Only exploitability data can, right? And so the final pillar for me is autonomous capabilities. When you're thinking about executing, an ecosystem of MCP servers, you should always be asking yourself, what is the action that this specific MCP server will unlock for me that will help me extend or expand the scope of automation that's possible by the workflow. And so, querying capabilities is going to tell you what's wrong at the end of the day, but having access to autonomous capabilities in the cycle then lets AI fix it, prove it's fixed, and that's what closes the loop, right? So triggering tests, verifying fixes, updating systems without human dependency, really being able to drive that find, fix, verify cycle. That's the extension of automation that changes outcomes for teams entirely. But where does this expert level exploitability context come from, right? And so there's a natural evolution of the story that we see in the security space. We started pretty simply, right? Phase one, we were in the era of rules, signatures, protocols, things like that. We whitelisted the good stuff, we blacklisted the bad stuff. So it's something like, hey, if a packet matches signature, go block it, right? The problem, attackers evolve faster than signature updates, and it's likely trying to stop. It's like it's like trying to stop every possible crime by listing every known criminal's face. Simply, it's not going to work as soon as they wear a mask, right? So phase two, we moved into the next gen anomaly detection stuff. We got smarter. We started using machine learning to identify unusual or anomalous behavior. So if activity deviates from baseline, alert on it. And this was progress, right? It became then a battle of speed and trust. False positives everywhere. Alert fatigue sets in. Teams stopped trusting the detections because half of them were, not useful to them. And so the third phase, the attacker's perspective, right? This is where NodeZero steps in. It's really where we represent a fundamental shift in the industry, because we're not looking to just scan for vulnerabilities. We don't want to just detect anomalies. We want to think like an attacker and prove what's actually exploitable. So it's like actually getting a home inspector to come in and say, imagine instead of a home inspector coming in and saying, your window locks look weak. That's going to be the traditional or even the next gen approach here. Useful information, but very theoretical. But instead, let's say you get a reformed burglar and they come in, they do an assessment, they tell you, I just climbed through the window, opened your safe, photographed your jewelry, and your alarm never noticed. Here's the picture of your crown jewels. One is theory, the other is going to be proof, right? And so that's the difference, right? NodeZero is we want to rely on the data set that we already know is working well with us. That's the difference, right? NodeZero provides proof of exploit, actual attack chains that are executed safely within the environment, downstream impact that's mapped to show what else attackers can reach, blast radius analysis to show you the cascading effects across your other infrastructure assets, and then even contextual prioritization based on your infrastructure, not just the generic CDSS score. And then if you're thinking about even what we do with like a rapid response, that's where this makes it even more powerful. We're already establishing that baseline. So we do continuously, through autonomous pen tests, give you baseline exploitability intelligence. However, we also have that rapid response testing. So the scenario would be, well, when Log4Shell dropped, how long did it take your team to know if you were actually exploitable? Was it days of emergency research? Is it weeks? Was it months? So with rapid response, right, we give you that answer in hours, even minutes, with proof, not probability. And then that sets us up to be able to provide to the approach a game-changing solution to being able to understand how to use continuous pen testing alongside the trust in the findings that we have, to being able to inject that same trusted intelligence into automated workflows, right? So let me show you what that looks like with a couple of these examples. Just an FYI, I will get to questions towards the end of the session here. Cool. So the DevSecOps perspective, if I'm showing you the art of possible when offensive security intelligence becomes accessible across a development lifecycle, without requiring every engineer to become a penetration tester, right? So traditionally, red team knowledge stays with the team. Developers get CVE numbers and CVSS scores. And so it's like a mechanic who only says, check engine light is on with no diagnostics, right? NodeZero provides that full diagnostic, what's wrong, why it matters, how to fix it. And so the plan, right, if you sort of like take a couple examples out of the CI/CD pipeline here, what you're looking at is, what are my top exploitable vulnerabilities? findings, right? This translates immediately to, let's say, 3 findings that have proof of exploit and lead to data exfiltration within a customer database. Decision immediately made for you in seconds. On the code side, it could be something like if you're using, generative AI for coding or generating code, even being able to say, hey, use the fix actions that you get from NodeZero to generate infrastructure as code fixes. And so specific remediation guidance is translated into actual code, and developers are empowered with expert knowledge. And so this is going to be the breakthrough, right? So launch another pen test, tell me if there were any security regressions. That triggers autonomous pen testing. There's immediate verification that comes through. And so developers know if changes broke security before it actually enters production. A developer who spent, let's say, 3 hours researching in the past now gets actionable intelligence in minutes. And that's not just faster, right? It's the difference between having a reactive security approach and building it into a daily workflow. And so this pattern then continues through release, deploy, operate, monitor, and at every stage, exploitability intelligence through natural language can be achieved. And so we're giving every engineer access to attacker perspective intelligence. And they start to understand why something matters because they see the exploit path. And so that's the democratization of offensive security knowledge across your organization. And even if you're not necessarily ready to take advantage of generative AI within coding, let's look at a complete workflows where we can bake this into an automated fashion, right? And so if you're looking at infrastructure as code vulnerability workflows, there's a before and after that tells a pretty clear story into what we're trying to get to here when you start to inject NodeZero context. And so here, like, we see a pretty well-designed agentic AI automation. When a infrastructure as code vulnerability triggers, we run code analysis. We have a bunch of logic gates based on rule-based events. AI agent steps in. We can create automatically some incidents, and then we can send it off to human, right? When we start to bring in NodeZero into the story here, that story changes where we're able to do fancy things like just deploy a tripwire to serve as Overwatch, to buy your team time for highly critical, publicly accessible weaknesses. And then it essentially is able to improve, right, your decision making from going from generic vulnerability data to being able to actually focus on the context that NodeZero provides. And so, that's what's possible through this exploitability intelligence. Right at the start, you see in this flow, we ask, hey, does NodeZero have proof of exploit? If that asset wasn't tested, we can launch a pen test immediately. We're not wasting cycles on theoretical problems quite yet. And so in detection and analysis, then we move into being able to rank by context score. Context score defined by the level of exploitability, the downstream impact, the scoring that we use in NodeZero itself. That maps out to all the impacts that you can get, all the assets that you can touch, if it was a regression finding, and then any recommended fix actions for the specific issue at hand. So then logic gates start to get way more sophisticated, right? If a pen test completes, proceed. If regression is detected, escalate. If context score and impact is above a specific threshold, take the critical path and let me know right away. And so the routing incident in and of itself becomes highly more confident in the decisions. The false positives drop. You can start to, you can start to implement, deception technology by dropping tripwires to cover your back. And then, messages contain, right, actionable intelligence at the end. You're able to capture all this context from all across this workflow, and then have it automatically generated within a Jira ticket. And frankly, for me, as a former blue teamer, that's actually one of the best use cases that I enjoy. And so what's really interesting, though, is by pulling in that third pillar that I talked about earlier, we get to also introduce a new step in this workflow, thus expanding the scope of what's possible with a single workflow. So it's the automated verification loop that you can see after the human approval here. What's interesting is you can then, right, if you use one-click verify to target, to use a targeted pen test to see exactly what was fixed and if it worked. If it's still exploitable, you can make the determination to cycle back to remediation. If it's not exploitable, success, right? You have proof of not exploitable, and that means that the fix was effective and that your team is operating, at speed. And so post-incident, the annotation really becomes a more confident fix, check mark. You're able to more confidently track regression over time. You can easily generate executive summaries, update Jira, like close evidence, whatever, you name it, right? And so the early proof of concept, right? It checks it creates a additional filter for noise before human involvement is necessary. The second breakthrough moment would be that context-driven prioritization comes into play. So it becomes exploitable path to domain admin affecting 47 production servers, not just critical CVE. The third thing is autonomous verification loop is going to close that trust gap. So it becomes hours to verify, not days. Fourth is going to be that regression elevation is going to naturally, being able to elevate regression is going to naturally adjust and fix processes that I find to be broken when you have human in the loop, and that lets you then treat that similarly as any other vulnerability that you're trying to address. And so, by finding the proof, you can fix with confidence, and you can verify with certainty, and the complete loop is going to, is finally possible to be closed in an autonomous fashion. And so if we're looking at the typical vulnerability prioritization workflow, I think the biggest challenge most organizations face at the end of the day is going to just be the mountain of vulnerability scan results, right? So this diagram shows a typical vulnerability prioritization workflow that I've employed in the past. So you first, identify the vulnerability. Someone has to go and research it. Then they go through somewhat of a decision tree to say, can it be remediated? If yes, go apply the patch, and then validate it as done. If not, can we at least mitigate it? What are the mitigation controls that we have available to us? And then after we apply it, we need to go and revisit based on the risk acceptance exploration. And if it's like a no, it's just, all right, well, I have to just accept the risk outright and then loop back when the time comes. For me, this is vulnerability whack-a-mole, right? You're reacting to whatever pops up with no visibility into what's actually dangerous. And so then the problems compound. This starts after the vulnerability is found, it's purely reactive. Human research is required for basically every finding, which does not scale. There's no context on exploitability. We're treating all vulnerabilities equally. And validation means we think we fixed it, not we proved it's fixed. So, excuse me, the loop doesn't actually close, right? You're waiting for the scan to run again next week and hope it doesn't show. If you're at a large enterprise, you might have another dozen of these, workflows set up for micro steps along the way, and that's going to require an immense amount of human in the loop. And so, with the agentic AI workflows in general, right, we've made some really good progress. I've seen some agentic AI powered SOARs. It represents a significant step up. Don't get me wrong. With simple automated playbooks. Now, when we're pulling inputs from multiple sources. So in this example here, we detected vulnerabilities. We are using the example of we pull the asset map from Exonius, and we have business context from Google Drive. And so we're enriching this vulnerability context, right? The CVE data with potential impacts. We see the asset status, whether it's a crown jewel, how important it is to business, configuration information, business criticality, right? They all feed into the severity score that we're calculating here. And so then, this is consolidation really at scale. We've eliminated a lot of the manual work that already needs to take place. And if it's high severity, we can quickly move to remediation. But human research to validate exploitability, to research potential fixes and update JIRA is still relevant here. And so then we need to then inject and talk about having a verification step. Typically, this looks like, for this flow, just checking the asset version, applying remediation methods, and then doing service level checks or package level checks, things like that. Verify if it should have been fixed, and then close the loop. Wait for the feedback to come back, right? And so this is genuinely better than the traditional approach. Don't get me wrong. We're consolidating context from multiple tools, so we have automated enrichment taking place, and the decision support is definitely improved. But we're working with ultimately generic vulnerability data, not exploitability proof. And so humans are still required for the critical validation step, right? Research exploitability is ultimately manual work that doesn't scale, especially if you don't have the specialist for it. And verification is checking versions, not proving the exploit path is closed. So the trust gap still remains, and this is the ceiling for agentic AI workflows without exploit level intelligence. And so watch how NodeZero can supercharge this already pretty sophisticated workflow, right? So what we're doing here is we're still pulling from multiple input sources, but notice what's different, right? The detected vulnerability already has NodeZero's proof of exploit attached. If the affected asset hasn't been previously tested, we can launch a pen test immediately. And so there's already this autonomous capability that we can lean into. And so before analysis even begins, we can make sure that we already have proof that this vulnerability is exploitable in this environment. We're not researching, we're acting on evidence. So the enrichment splits into two streams, right? First, NodeZero exploitability context, proof of exploit, threat actor mappings, minor TTPs, EDR efficacies, fix actions, downstream impact, regression, all the stuff that I talked about. And then traditional context, asset status, business criticality, complexity from GRC, things like that. So in prioritization, we're using NodeZero context here as the primary driver, but we're elevating regressed vulnerabilities because that indicates a process problem. And so high severity findings get recommended fix actions immediately. And so we can get to an action plan from the moment of detection. And that, for me, is one of the game changers, right? So in remediation, instead of research to validate, we have different options. We have, is it patchable? Can we reconfigure it? Can we mitigate it, or do we have to accept this risk? The recommended fix actions feed directly into these choices. And so humans are still applying the remediation methods appropriate, right? We want to put up guardrails where necessary, but the decision-making is still automated, right? The research itself is eliminated. So the action plan is pre-generated. And then verification, the game changer here, again, is deploying NodeZero one-click verify. This is going to allow you to then automatically launch targeted pen tests on the remediated finding. So if it's still exploitable, you can run a mini loop, essentially, and we cycle back. If it's not exploitable, we verify with proof, and then we can update JIRA tickets with the working fix and evidence that it's actually not exploitable. That gives you the ability to then close the loop with evidence. And so the contrast, right, is pretty clear. In traditional, we're finding vulnerability, we're trying to research what it means, guess at the priority, try to fix it, hope it's fixed, and then typically like 30 to 90 days later, when the next scan runs, we can confirm it. With agentic AI and generic data, we're finding vulnerability, we auto-enrich with some context, calculate priority, And then we have to manually research the actual exploitability, fix with guidance, figure out if it's, if it still matters, and then see if there's proof the fix worked. With NodeZero, however, right, we're finding vulnerabilities with proof of exploit. It's what we've been doing, the bread and butter of the product itself. And with its ability to wrap this up nicely for an LLM to consume, we're essentially auto-enriching with exploit path, plus the business context. And that lets us then prioritize by demonstrated impact. And it lets us get to pre-generated fix actions and a much easier, clean-cut approach to being able to understand what type of fixes you want to be able to apply, and then being able to inject autonomous action to actually verify and close the loop with hardcore evidence, right? So for me, I think the 4 critical outcomes that you achieve is trust and prioritization. Research time becomes action time. The find, fix, verify loop is actually, it's accomplished. The fix worked before you're actually moving on and closing the ticket. And then there's an obvious steady stream of regression testing, regression detection. So instead of having the 10,000 vulnerabilities to triage that we talked about in the beginning, you get 10 proven exploit paths with fix actions. And that's the difference, in my opinion, between drowning in alerts and swimming in solutions. So if we zoom out then to the program level, right, how these workflow improvements cascade across your entire security operation. Traditional agentic AI, let's say after a vulnerability scan completes, excuse me, AI does initial routing, humans do the hard analytical work. So they're investigating, they're verifying exploitability, they're determining action, and then AI then will step in and do administrative tasks, not strategic decisions, right? The transformation here is that with the NodeZero ecosystem, after NodeZero test completes, AI gets enriched data from the start, proof of exploit, weakness details, fix actions ranked by context scores, and then Jira issues can be created with the full context from the get-go. And then you have options to be able to integrate across the ecosystem. So manual work shrinks dramatically. We can review tickets with preloaded context, and that lets us get to a faster remediation loop. And so if we're being conservative with the math here, let's say eliminating research time saves even 90 minutes per finding. That's going to be 1,500 hours back monthly for a team that processes 1,000 findings. And so that's more than one full-time security engineer redirected from doing administrative work to strategic improvements, right? So it's not just the time, it's the quality that we're driving, decisions based on proof, actions that are verified, processes that improve through regression testing, and teams are then able to focus on strategic work. And to me, this is what mature agentic AI security looks like, using multiple tools connected through MCP servers with an LLM orchestrating workflows, but the secret sauce, exploitability intelligence at the foundation. Without it, you're ultimately automating guesswork. With it, you're automating certainty, right? So just to close it out, we started with the fundamental question, right? Which vulnerabilities can attackers actually exploit right now, and what happens when they do? That question matters because in the era of machine speed threats, we need machine speed responses, but only if those machines are working from truth, not theory. And so the 3 takeaways from today be first, shift from detection speed to fix velocity, right? Machine speed threats demand machine speed responses built on exploitability truth. So the fix ops revolution that I talk about is here. It requires intelligence that separates what matters from noise. The second thing is treat your AI ecosystem like infrastructure. The quality of your MCP integrations absolutely determines whether AI amplifies your security posture or is just automating guesswork. So great MCP servers expose expert data in ways that LLMs can actually use. Third, close the verification loop, right? Finding and fixing vulnerabilities means nothing if you can't prove the fix worked in a scalable fashion. Autonomous verification at machine speed, right? That's the breakthrough that you need to enable true confidence in the security posture, as well as the decisions that your automated workflows are making for you. And so whether you're a NodeZero customer or you're evaluating your options, here's my simple challenge. Calculate how much time your team spends researching and prioritizing vulnerabilities every month. And then ask yourself, what would change if that time was spent on strategic security improvements instead, right? The NodeZero MCP server alongside the Agentic AI ecosystem is absolutely not about replacing your team. It's about giving them what attackers already have, automation that acts on truth. And so we're entering an era where security teams will operate more like air traffic controllers than firefighters, right? You're not going to manually, hopefully, you're not going to be manually putting out every fire. You're overseeing instead autonomous systems that can detect, prioritize, fix, and verify at machine speeds. But in order to do that, those systems need truth to operate on. And so we already know, right? We've talked about this before, the NodeZero story. NodeZero has always provided that attacker's perspective, the ground truth of what's actually exploitable. The MCP server then takes that truth and makes it available to the next generation of AI-driven security workflows. And so, if you're already a NodeZero customer, MCP server is already available for you guys. Go start experimenting, building workflows, share what you discover, and I'd love to learn alongside you guys. And the attackers are already using AI. Cannot emphasize that enough. Question really isn't whether defenders will use AI too. It's whether our AI will be grounded in truth or drowning in noise. And so, look for ways to not only just supercharge your AI, but build it on a foundation that matters. In our case, what attackers can actually exploit in your environment. And so, there's a couple of questions I want to answer here. So, okay, so the Demetrius, thank you. I was having some, my throat was feeling a little scratchy today. The MCP server connected to database with NodeZero. So the way to think about this is at the start of it, we highlighted that the MCP server is essentially going to give you access to anything you can do within NodeZero to give you a headless experience, right? So every single one of our findings is tied to either a known CVE or in the case of Horizon 3 specific, sorry, Horizon 3 specific tools, techniques, and procedures. We will have the context readily available that can be accessible to the MCP server, and so you should be able to then inject all the CVE context directly into your ecosystem. Antonio, H3 determines exploitability. We at the core of it, and we'll definitely get you set up with the demo. At the core of it, what we're doing is we run benign code execution to prove that if I were an attacker, I was in the same position as the attacker, this is what I could see. Examples of something like this is, let's say we're trying to prove that we have domain admin access. All we need to do instead of dropping a payload is run a command like ls to show you everything that we can see, everything that we have access to, and everything that we can touch. And so we are able to then chain together, right, these safe to run production exploits to show you then the ultimate impact by actually utilizing the things that we find during each pen test. Does it take possible issue that can occur? So I think the question here is how exactly is a fix deployed with this architecture? It depends on the complexity and the buy-in essentially of the organization, and what capabilities they, let's say, are comfortable with you guys utilizing in an agentic AI workflow. Um, if you, if naturally as a part of the ecosystem, you introduce an MCP server that has access to certain protocols and access to being able to, take read-write action on certain things, then absolutely yes. This is where you can sort of start to customize based on your organization's risk preference, by essentially introducing the human in the loop, or human by exception rather, wherever you start to find that somebody wants actual eyes to look at it. To me, then it just becomes about how much can you enrich the data before it gets to me. Even if you're not using Gen AI for code generation, you're still able to make better decisions as someone who might not be a specialist in offensive security. Yes, I believe that we will be sharing this as a recording available to everyone. So we'll make sure. The biggest threats I see companies facing right now. So I think tried and true, right? Attackers are still just logging in. At the end of the day, I think what all this, like all the LLMs and the automated fashion that I'm seeing with attackers is that it really hyperscales their area of coverage. They can spend less time focusing on individual specified targets and instead can have higher quality outputs just using Gen AI. And so it extends anything from like phishing as a service using Gen AI to generate deepfakes for voices, for text itself. You're probably not going to get the Nigerian prince type of scams anymore because they can just pull at your heartstrings based on open source intelligence available to them. And so I think it's to me the biggest problem is still going to be the little things, the tools and techniques that don't necessarily qualify for a CVE, but are still the most popular use cases for an attacker. We've seen it across thousands and thousands of pen tests. One of the most popular attack technique that attackers will still use is to take advantage of SMB signing not required, right? Rated at like a 0.1 on the CVE, on CVS's scoring. But for us, it's constantly one of the most popular openings for us because it lets us leverage what we found from a man-in-the-middle attack to actually just pass the hash and log in. And so while it's great and it's fancy to be able to say, hey, we're looking for anomalies from what we anticipate to be good or bad, if they're using known good channels, right, you're not going to see it. And that's the thing that you absolutely need to be focused on. Let's see, what will happen if any new threats comes out? Check. Yeah, so just to make a distinction, because we as a company are attacker focused, right? Of course, like when there are popular, headline CVs and all that, one of the first things that we've already done is we will go in and try to see, based on the actual vulnerability itself, what the ease of use is, right? How easy is it for me as an attacker to take advantage of it? And typically, the more urgent stuff is going to be publicly accessible vulnerabilities, or assets rather, remote code execution type stuff, things like that, right? And so for us, what we're trying to do is we want to tackle the 1% of the thousands and thousands of CVEs that are actually being used to exploit organizations. And so for us, our focus is going to be primarily towards like the CISA Kev items, right? And so as a part of our rapid response program, We're constantly either looking for 0 days and end days ourselves, in which case we have, we've been credited with finding or discovering these, multiple times in the past, in which case our customers have first right access to the check for exploit, right? We were able to get log4shell, for example, a check for exploit within a week or two. And so for us, right, it's all about making sure we surge when we find a very vulnerable vulnerability so that your team doesn't have to be doing the offensive security research. And instead, you can rely on the attackers on our team to be looking through and making decisions on what we think is most valuable to be looking for. Does it also, if there are automated fixes, does it also generate what the backup plans would be in cases they don't work? Yes. So I'll just caveat that with saying it does depend on the quality of your LLM. There are obvious differences, let's say, in reproducibility based on the quality of the LLM model, whether or not it has specialty, which, by the way, I don't think you need a specialized model in order to have success with any of the workflows that I showed you today. But I've personally have had great experience using Claude. It will, as a natural part of the system prompt of Claude, the LLM itself, it does work to create backup plans. And so you can always ask it to say, hey, here's like the circumstances, and hopefully based on the context that you're pulling in from other business units, you're able to make, you're able to generate a plan off the bat that's going to work. But if not, it's just as easy to be able to interact with the ecosystem again to try to figure out, okay, well, I just ran the one-click verify again. It proved that I'm still exploitable. What do I do next? And so it's going to start to think about, right, like that good colleague of yours, it's going to think about how can I fix this problem differently? And it's going to create a plan like that, which is awesome. How do you ensure the MCP server stays secure as an attacker? H3 would be a great target. H3 would be a great target. The primary thing is, off the bat, we have built with security as our first concern. In the past, when the first version that we released was a locally hosted model, we were never shy about attacking our own MCP server and then calling out what we would think to be potential flaws in the infrastructure. I will call out, as a whole, the industry is adopting and currently trying to figure out what the best security protocols would be for agentic AI workflows in general. For us, we want to do something that's tried and true. When you use the MCP server that we host, we rely on the same things that you guys use to log into Portal. OAuth 2.1, making sure that the access of read-write doesn't exceed what you as a user have access to as well. And so it's making sure that not only from the entirety of our infrastructure when a pen test runs and completes, you can obviously, you can guess that if we as a company were to get hacked, we'd be out of business. And so it keeps us up at night as well. We use these workflows internally to constantly stay afloat of all the latest things that are happening. We practice what we preach, right? And so that's the most important thing, is you should absolutely treat it like any other infrastructure. Please do not hard code environment variables with API keys in it, unless you're using like a controlled API that's refreshable, deprecatable, and coming from like a service level perspective. But yeah, it's protect your users at the end of the day, right? We still need to make sure that anyone who has access to your portal is protected in the right ways here. So I call out Claude specifically, but what about others such as Axage? Is the MCP server part of the... So yeah, the MCP server is accessible to everyone, all customers who have essentially a license and can use the API, have access to the MCP server, you're welcome to jump in. I know that if you talk to one of the federal reps from the DIB program that you are calling out here, they can absolutely take you through sort of like how to get to it and what the setup looks like for it. I personally have not tried Ask Sage. Some of the other models I've tried out thus far, we typically we're using anything available like through Bedrock for testing. It's going to be the Claudes, the ChatGPTs, Geminis, even Olama and DeepSeek, for example, all models we've used and have demonstrated success for. Cool. Will we still get all the boring vulnerability since? Yeah, so you will still get findings about the boring vulnerability reports in NodeZero. This makes no difference in what we're looking for during the pen test. It's making it, in fact, just more accessible to the organization to be able to get the data out of the NodeZero pen tests. So yeah, absolutely. Like just because we're looking for the 1%, it doesn't mean that we don't care about the other attack techniques that we know attackers have used in the past. And so I think the cool part about it really is that I've seen some success where some organizations have a very specific branding like template that they want to follow for all reports that they pass up to auditors or CISOs or boards, et cetera, et cetera. I've seen some cool instances where there's a mini workflow that's created to essentially help generate these reports. And then if you think about it then in the context of everything I talked about, have access to all the findings within NodeZero, and then you can pick and choose what you want to actually be featured into that vulnerability report. That's the exciting part. It doesn't have to be just the critical stuff where we're not picking and choosing. You can use the context scoring any way you want. That's the beauty of it. Nathan, I don't personally, but that's a different webinar, I think. Cool. So thank you guys again for joining. If there aren't any additional questions, I'll stay on for another minute or two for any stragglers who are typing away. But otherwise, thank you guys again for joining. Please, please feel free to reach out to me directly. My email is brad@horizon3.ai. I invite you guys to come poke around and see what you can do with the MCP server. If you need a sounding board to help you guys come up with some cool use cases, I'm open and I'm all ears. Yes, Nathan, Tenable has their own MCP server, and I have customers who have used it together. Yes, we will send out a link for a recording. Brad, it's just my first name at horizon3.ai. Awesome, guys. Thank you so much for coming. Let's build the future of security together, guys. Thanks again.